All right, the cost approach to value. See, personally, I think this is by far the easiest of the three from a math perspective, because it's the same 3 steps every single time, over and over and over. Okay? What kind of properties did we say we value using the cost approach? Special use properties. Special use properties. The sales comparison approach, which we just finished, was used to value what kind of properties? Residential or vacant land. Okay? Well, that's residential, right?
Well, but residential could also be profit earning.
That's what I'm saying. That's not residential. The mistake you're making there is those aren't residential properties. Not from a valuation standpoint. If I am buying it for the purpose of producing income, what kind of property is it? It's income producing. So the sales comparison approach is used for residential properties, which are properties that we intend to live in. Okay? So the cost approach is used for special use properties. Things that we don't live in, things that we're not going to make money with. Special purpose properties. We still need a way to value them because we need to know how much they're worth for insurance purposes. So there are 3 steps, and only 3 steps. And they're always the same 3 steps. There's no variance, there's no variation, there's no, if it comes at you this way, it will only come at you one way with the cost approach, and it'll be the same way every single time. Step 1, we need to know the land value. Separate out the land value. And most of the time in these questions, they'll just give you the land value. I guess they could tell you, oh, it's 3 acres in an area where land is valued at $25,000 an acre. Maybe. But most of the time, they're just going to tell you the land is worth this. So step 1 is just come up with the land value. Step 2, you're going to add the replacement cost of the structure. And usually replacement cost is going to be just square footage times a cost per square foot. Okay? So replacement cost usually is just going to be number of square feet times the square footage. Cost per square foot, I'm sorry. And we'll give you several examples. Number of square feet times the cost per square foot. That's replacement cost. Now, you could occasionally see something called a reproduction cost. Reproduction cost is more expensive than replacement cost because reproduction cost involves reproducing the structure exactly as it existed before. Not just building it same size, same use, but brick by brick, mortar by mortar, reproducing it exactly as it was. What kind of properties would we want to do that with? Historic properties. Historic properties, we would estimate a reproduction cost versus a replacement cost. You don't need to know how you go about doing a reproduction cost because you won't have to do that. You just need to know it's more expensive and it's used for historic properties. Which makes sense if you think about it, right? We're going to deal with replacement cost. And how are we going to deal with replacement cost? Square foot method. The book introduces you to this idea of the quantity survey method or the unit in place method. You're never going to deal with that. They're more accurate than the square foot method, but they're way more involved and something you would never see. Okay? Quantity survey method or unit in place method would be like we have 27,500 pounds of nails. We have 47 million board feet of lumber. We ain't doing that in here. It's just way too complex. And so that's all you need to know. They're just detailed. Are they going to be more accurate? Yeah. Well, of course. But who's got time for that? Not us. Okay?
Not if I'm only charging $30 for it. You're not getting all
That's exactly right. If you're doing a $50 broker price opinion.
That's right. I will do what my dad told me.
Exactly.
You bid high. I'll do it for $200. And they say.
Yes, ma'am, Michaela.
So you said the unit in place method and the quantity survey are the two that we won't use.
Correct, because they're way too detailed. Michaela might use them because she likes super detailed stuff. Travis likes the 10,000 foot approach, right? I want to know how many square feet it is and how much per square foot and then get out of my face, right?
I like how easy your approach is. I just can't help that I'm a detailed person.
Yeah, I know it, and I'm not saying you should help it. I think it's a wonderful thing. But I think the best way for me to describe it for you is it would be the way you would do it, because you'd want to know. You want to know how much is that receptacle worth, right? Travis doesn't care, right? So I'm the square foot guy. You're the unit in place girl, right? We also, and so I'm going to back up slides here because I want you to see the 3 steps again. Step 1 was value the land. Step 2 was come up with the replacement cost, which we said for math purposes is just going to be that square foot method. And then step 3 is we're going to subtract something called depreciation. Well, we just dealt with appreciation as an adjustment when we were doing the sales comparison approach, right? Here, we're always going to be subtracting depreciation, because when you're talking about these kinds of properties, they're always depreciating. There is no such thing as appreciation in a cost or special use property. That's because it's never going to sell. There is no market going up or down here. There's only usefulness. And what happens to the usefulness of any building over time? Not only does it goes down. If you're talking about something like a fire department, a police department, a library, a community building, a university building, it is at its highest value the day it's built, and it does what every single year after that? It depreciates, becomes less useful over time. And so that's what depreciation is. It's just a loss in value over time. That's all. We're losing value, and we're losing it specifically because time is passing. So in your book, and this is going to be the last topic-based thing in the cost approach here before we really get to the math of it, they talk about the different types of depreciation. You will probably see this on a test to be able to identify the different types of depreciation. What does the word obsolete mean?
Not really at the value, or it doesn't matter.
It's outdated.
Outdated, right? So when we talk about obsolescence from the standpoint of depreciation, means a loss in value because of something that's no longer wanted or no longer desirable or no longer useful. So an obsolescence is anything that reduces the value of the property because it's no longer wanted or useful. It doesn't mean it's broken, it's just not useful anymore. So for example, brass plumbing fixtures in a house, like shiny, as they would say in eastern North Carolina, yeller brass. Not yellow, but yeller. That bright yeller stuff, right? Blinging. That's an obsolete... Please no. Please don't let that come back. Please don't let that come back. I'll keep the oil rub bronze and the brushed nickel any day, right? I go in there and I look at that stuff and I'm like, oh, oof, hurts my eyes. So that's an obsolescence because it's no longer desirable. There's nothing wrong with it. It functions, correct? So that's an example of an obsolescence. A functional obsolescence means something that still works, but it's just outdated. It's functional, but it's what?
Outdated.
Obsolete, outdated. Does that make sense for everybody? An economic obsolescence has nothing to do with the functionality of the property. An economic obsolescence actually isn't even on my property. It is a reduction in value, but it's a reduction in value because of something that happened completely out of my control.
It can
So I got a dump next door. Can I control that? No, it's not on my property. I'm down the road from a paper mill. If you've ever driven near a paper mill, you know what I mean. Aranza's shaking her head. She has no idea what that means. They don't smell good. They stink. Eggs is one way to describe it. There's another. They smell very bad. That's an economic obsolescence if your property's near it. Because if the airport, if I have a property in Briar Creek up here, the airport is an economic obsolescence for me, because people hear that and they're like, God, I don't want to listen to that all the time. So they pay what for the property? Less for the property. Can the people who own those properties do anything about that airport noise? No. That is an economic obsolescence because it's outside of their control. Whereas a functional obsolescence is within my control because it's something I can do what with? I can change it. I can change it. Does that make sense for everybody? Now, let's talk about this incurable versus curable stuff. Incurable does not mean I can't fix it, because anything can be fixed. Incurable means it's not economically reasonable to fix it. It would cost so much to fix it that it's not worth it. So, like for example, an incurable functional obsolescence would be the house has no heating and air. There's nowhere in the crawl space or the attic to put ductwork. Is that functionally obsolete, that it doesn't have heating or air? Yeah. Well, we could still put heating and air in there, but we'd have to do like exterior ductwork or these individual units in every room. Is it probably going to be worth the expenditure to do that in that particular home? No. It's not. There you go. There's the juice not worth the squeeze. I haven't heard that one in a long while. So, but you could do it, but it's not worth doing it. Does that make sense for everybody? That's incurable. Curable is not only could you do it, but it makes economic sense to do it. Okay? Functional obsolescence, what is it? Something that's what? Not desired, outdated, but you could do what about it? You can fix it or change it. It's within your control. Whereas an economic obsolescence is something that is outside of my control, completely outside of my property. I can't do a thing in the world about it. That's an economic obsolescence. Now, depreciation as far as a math problem is actually much easier than that. We need to know some terminology. We need to know effective age and economic life. The economic life of a property is how long we expect that property to remain economically useful. Now, properties usually outlast their economic life structurally. We're not talking about how long it would take the thing to just fall down into oblivion. There are plenty of properties, if you drive around in most cities, for example, that structurally are still very sound, but they've outlived their economic life. How do we know they've outlived their economic life? They're vacant. They're still there. It's an old warehouse. I mean, you drive around eastern North Carolina, you'll see tobacco warehouses, for example. There's nothing wrong with those buildings. They still have plenty of physical life remaining, but their economic life has been extinguished because they're no longer economically viable. Does that make sense for everybody? So economic life is just the amount of time we expect that property to remain economically viable. City in the world with the shortest economic lifespan, Las Vegas, Nevada. Look at those hotels, those resort properties. 15, 20, 25 years, what do they do with them? Tear them down and rebuild something else. Clearly, they are still fine from a structural standpoint, a functional standpoint, but economically, they've outlived their lifespan. So, every property is going to have a different economic life. The idea of an economic life is that it goes from 100% useful to 0% useful during that time. Does that make sense? Everybody good with that? The effective age is just how many years into that cycle we are. So when we look at it as a math problem, first thing we're going to do is divide 100 by the economic life, because it goes from 100% useful to 0 during that time frame, right? So what we're really trying to figure out is how much does it depreciate per year. So for example, if we had a 40-year economic life, the first thing we would do is take 100 and divide it by what? By 40. And that would give us our rate of depreciation. It depreciates 2.5% annually. Okay? So the first step is to divide 100 by the economic life. The second is to multiply that times the effective age. That gives you your depreciation. So here's an example. It says a building has a replacement value of $125 per square foot and is 2,000 square feet. The building has an economic life of 50 years and an effective age of 15 years. How much has the building depreciated? Well, we need to know a starting point for the building first. So we're going to multiply the cost per square foot times the size of the building. $125 a square foot times 2,000 square feet. How much is the replacement value of our building here? $250,000. Does everybody see where that number comes from? Okay? That's if it was brand new. Is it brand new, though? Because remember, the only reason we're doing the cost approach is for what purpose? Why do we do a cost valuation? Why do we need to value these special use properties? Insurance purposes. Think about the insurance on your car. You go wreck your 3-year-old car. Are they going to buy you a brand new one, or are they going to pay you a depreciated amount? Depreciated amount. That's why this matters here, because we're doing this for insurance purposes. So that $250,000 value is if the building was brand new. The insurance company's not going to pay us $250,000 though. They're going to depreciate that building. So we need to figure out how much it depreciates per year. We take 100 and divide by the economic life. And how long do we expect this property to last? 50 years. So 100 divided by 50 equals 2% per year. Does everybody understand that? It's always going to be 100 divided by whatever that economic life is. So 2% annual depreciation, which is $5,000 per year. That's just the $250,000 times 2%. It's $5,000 annually. And how many years has it been depreciating? 15 years. It has an economic or effective age of 15 years. So we've got $75,000 worth of depreciation that building has taken. Yes?
The effective age, how long the building has been built?
The effective age, well, so Ashley's question is, I hesitate to answer this question. Ashley's question is the effective age how long a building has been built? For test-taking purposes, yes. In the real world, the effective age can be changed. Because what could I do to this building to change its effective age? Not even without tearing it down. I can improve it. I can remodel it. If I remodel this building and I gut it and all new fixtures and all new everything, I can roll the clock back on its economic age. But for your purposes on an exam, yes, it's just the age of the building. When you're doing these math, it's just the age of the building.
Is that why on all the listings it always says years since last remodel?
Yes, absolutely. Absolutely. Does everybody understand this idea of depreciation? Okay, so going back to the math, and by the way, this is the math, this is just exactly as the math formula shows up in your math packet right here. I just brought it back in. The 3 steps, what do we start with always? The value of the land. And then we add what? The replacement value of the structure. And then what's step 3? Subtract the depreciation. Those 3 steps are going to give you your cost valuation. So there's no adjustments to be made here. There's no pluses and minuses and moving hands around. It's just 3 steps. Land value plus replacement cost minus depreciation. Now, be careful with the depreciation. Just like the appreciation that we were doing in the sales comparison approach, you don't want to start doing your math first. You're going to depreciate the building's value, just the building, not the land. We don't want to depreciate the land. So don't add them together and then do the depreciation. The depreciation is just of the replacement value. Does that make sense for everybody? Okay? Don't depreciate the land. So let's take a look then back in your little handout packet at number 11. Let me see what number 12 is. Number 11. You got all the room to work with there? A worship facility is being valued for the purposes of determining the cost of insuring the facility. See right there, that verbiage should tell you you're doing a cost approach because it's for insurance purposes. The building is located on a lot that's valued at $96,000. It has 4,200 square feet of usable area, and it's 15 years into an expected economic life of 50 years. Using this information and knowing that the cost of replacing the structure itself based on local building costs is currently $110 per square foot, what's the estimate of value for this property using the replacement square foot method of the cost approach? So, let's just write down my 3 steps. What's step 1? Land value. Okay. Step 2. What am I adding? Replacement value. And then step 3, I'm subtracting what?
The depreciation of the structure.
Minus depreciation of the building. So I'm just writing those down so I have a guide of what I need. So if I go back to my question, did they give me the land value? What is it? $96,000. I don't even have to do math. Plus replacement cost of the building. And they told me that the building is 4,200 square feet at how much per square foot? $110. So I'm going to just go down here and do $4,200 times $110 per square foot. What do we come up with? $462,000 is the replacement cost of my building, right? So I'm going to go right back up here and put plus $462,000. Almost home free. What's step 3? Minus what? Depreciation of the building. So the building started at $462,000. That's what I'm depreciating from, correct? What did they tell me about the depreciation? They told me that it was 15 years into an expected economic life of 50 years, right? So when I'm figuring out depreciation, the first thing I want to do is take 100 and divide it by the economic life. What's the economic life here? 50 years. So what is my annual rate of depreciation? So that's 2% per year depreciation. So $462,000 times 2%. What is that for annual depreciation? $9,240 per year, right? Everybody agree with me on that number so far? And how many years has it done that? 15. So times 15 years. And what does that equal? $138,600. $600 in depreciation. And so I'm just going to bring that right back up to the top, minus 138,600. And now it's just simple math. 96,000 plus 462,000 minus 138,600. 419,400 is my cost value of that property. How's that one for you? Not too bad. That's 2 of the 3 methods of valuation knocked down right there. We've done the sales comparison approach. We've done the cost approach. That only leaves what kind of properties left? Income properties. And we will talk about those on Friday. We will talk about those on Friday. We will close out valuation on Friday with the income capitalization.